Vinodini ma'am, you can start the session.
Ready? Sivaparan sir, shall we start, sir?
Yes, madam, I am ready.
Okay. Dear participants, I welcome you all for the formal session of day 4 of 1 week international FTP on trends and innovations in Industry 4.0. I invite Mrs. M. Vinodini, Assistant Professor, Department of ICE, ABC College of Engineering, to introduce the eminent speaker of this session.
Good morning, one and all. The eminent speaker of this session is Engineer Sivabalan Silvarajan. He is a prestigious alumnus of our Instrumentation and Control Engineering Department. He is presently working as Senior Design Engineer role for Qatar Petroleum Projects. He has more than 14 years of experience as Control System and Instrumentation Engineer in oil and gas, power and petrochemical industries. He has worked in multinational environment and executed projects in China, Singapore, Germany, Austria, France, Switzerland, UAE, and Qatar. I cordially invite Engineer S. Sivabalan to share his thoughts in the topic Industrial Control Systems and Cyber Security. I welcome you, sir.
Thank you, Vinodini madam.
Thank you, sir.
For the wonderful introduction. So shall we start the program now?
Yes, Sivabalan sir. We shall start.
Okay, madam. So I can able to share my screen now. Can you able to see my screen now?
No, sir.
Oh, no, sir.
Okay. I hope you can able to see now.
Yes, sir. Yes, we can see now.
Started presentation. No, yes, sir. It's visible.
Okay. Okay. Good morning, everyone. Once again, it's a fresh and cool morning.
Good morning, sir.
This is 7:30 a.m. in Qatar now. So before starting the program, I would like to thank the organization committee, Honorable Justice Mr. Venkatramanan sir, and patents Senthil Kumaran sir, Director, and Principal sir Sundar Raj, Organizing Secretary Mrs. Vadivari madam, and Convener Surya Prabha madam, Arnold Chelvan sir, Vinodini madam, and Steering Committee, Dr. C. Raj Kumar, Ravi Kumar sir, or Gopi Krishnan sir, Sharmila Devi madam, and Surya Prakash sir, for organizing such a wonderful international committee program. Like, this is the most important and prestigious program. While we are studying, we didn't get the opportunity, but at least nowadays we are getting grown and we have kind of technologies to go ahead with. Okay, today our topic is industrial control systems and cyber security. If I am not audible, you can tell me now, so I can adjust my volumes and all.
Okay, sir. It's fine.
It's fine now. Okay, then fine. Thank you, madam. So let us begin with Vinodini madam already given the introduction about myself, so I need to tell about anything myself again now. So let us go ahead with industrial control system and cyber security. Why I have chosen this topic particularly I have seen it. Our previous session, eminent speakers are already been covered with IoT and machine learning, how the automation, how the machine automation, machine tools, and artificial intelligence, and kind of cloud computing. This topic's been already covered, and I want to express the industrial experience and then how the cyber security is linked with our industrial environment. This is what I want to convey to our participants. So this is what we have chosen this topic. So our program's topic was like trends and innovations in industry 4.0. So I'll come to the industrial revolutions in the coming slides, and now we begin with industry 4.0, what it does. Basically, we can see that industry 4.0 is a fourth industrial revolution, which is characterized by the integration of physical and digital world. Why we can say physical and digital world? We have all things in physical, but our things are getting converted into digital. So our industries and as well as our technologies need to be linked with the digital world in order to enhance the application, as well as we need to get use of it. So that's what we are linking the physical device with the digital world. And it is enabled using advanced technologies such as artificial intelligence, robotics, and Internet of Things. We have round enough, we have already been covered this topic, so I don't want to get it into these topics again, but these are the advantages and upgradations in 4.0. The aim of the industry 4.0 is to create smart factories that are connected and automated and data driven, which is relevant to our recent trends of industries. This will enable business to the more efficient and reduce costs, as well as is increasing the productivity. Obviously, the current revolutions like 3.0 is almost reached the level, but we want to get it more efficient, and then we want to reduce the production and manufacturing cost. Then we need to increase our final base, as well as the increasing the productivity, so that we are enhancing into our technologies more and more and day by day. The main emblem of this 4.0 is cyber physical system, which we have covered in the first point itself. So cyber physical system is nothing but how our digital world is connected with our physical systems, as it will be the base of new production system, which will be controlled and monitored wirelessly by artificial intelligence software. So what are the highlights in this? It is actually, it is not ended up with 4.0. It is getting evolving like 5.0, 6.0, 7.0. It is like technology has always been endless. And then it is in complete automation and smart systems, and it covered with Internet of Things, artificial intelligence, big data, cloud computing, virtual realities, and then 3D printing, focus on sustainability. These are the things which has been covered in 4.0. So while we are discussing 4.0, we have not directly entered into 4.0. We have enough revolutions behind with. That is called industry 1.0, 2.0, as well as 3.0. The 1.0 is evolved in 18th century, and 2.0 is in the 19th century. Industry 3.0 is in 20th century. Now we are here with 21st century. So what does it industry 1.0? Industry 1.0 is first industrial revolution characterized by the shift from manual labor to the mechanization. Which means previously whatever the ancient temple, which in our states like Tamil Nadu, we have like so much of temples been built in the past years by our kings. In that time there is no mechanism, but they built such historical temples or many monuments. So such things are like since it is like famous and popular one, but it took a long time to make it build, as well as many of the laborers been affected personally. These are the things being avoided while we're using into mechanization. It is not completely been avoided, but we can able to reduce the potential of fatality. This revolution introduced of this steam power and driven machinery and use of iron and steel of the production of processes. The first factory were built and the production of goods increased significantly. The revolution led to the emerge of the large scale manufacturing and the growth of cities and towns. In the industry 1.0, we are get to know from the villages to towns and cities. So that is the first point where we're getting grown into the industrial life, we can say. So if you see the highlights of it, it is started in England. It is in the 18th century. From handicraft things to the factories, power sources are like water and steam. So in this stages only, slightly the electricity been entered into our life. Over exploitation of workers, which has been already covered. So let us go into industry 2.0. What is advantage from industry 1.0? So now we can see it here. Industry 2.0 is known as the second industrial revolution, was marked by the introduction of electricity and the use of new materials such as aluminum, petroleum, and rubbers. These are the materials we didn't use in the revolution of 1.0. It has been introduced here. And this revolution led to the innovation of assembly line and the mass production of goods. The invention of telephone and other communication technologies are revolutionized, and the way people interacted and they did the business. This revolution also saw the emergence of large-scale industrial organization and the growth of middle class. So this is the point which the middle class been getted into the today's life. Whatever we are living today, that was all around started in this stage only. So it is like in 19th century. It is like it started around 1817. And assembly line, mass production, and oil and electricity been evolved full efficiently. And let us come to industry 3.0. Industry 3.0 was known as the third revolution, industrial revolution, we can say. Now marked by introduction of computers and automation. Computers and automations been introduced in this industry 3.0. This revolution saw the emergence of digital economy and the rise of internet and e-commerce. We have started using this internet, and all the industries been started working with the computers and industrial, the man-made working with the machineries, which we are dealing directly with the machinery been getting reduced. Then new technology like automation or came into the process. For example, we can say in car manufacturing and many instruments manufacturing, these kind of factories gets introduced with this industrial automation. The invention of the computer and the internet revolutionized and the people where we communicated and did the business. So this revolution also saw the emergence of new industries such as software and digital media and growth of global economy. It was started around like 1970, which is 20th century, which is digitalization and automation of these highlights, and computers, mobile software, internet was used, and robotics also been introduced in this session. So regarding this industry 1.0, 2.0, 3.0, 4.0, this all been discussed very deeply in the past sessions, and then we will enter into the industrial overview. So before entering into the industrial overview, I want to show how industry is getting working. A small video I want to share it now. So are you audible now? You can able to hear it?
No, sir.
No, sir. Voice is not audible.
Okay.
Only play the video, sir.
Is it okay now? We can able to hear the voice?
No, sir.
No. Okay, fine. Okay, we do one thing. You can see the video and then I can explain myself. I think so.
Okay, sir. That's fine, sir.
Fine. Okay. So this one, what we are seeing now is how our oil and gas industry's rigs been constructed, because our oil and gas been introduced with without oil, there is no oil and gas now. So how the oil been extracted from the field? This is what the first step in oil and gas. So just you see the whatever we are seeing, the bottom structure is on the this is the bottom of sea now. So this is installed on top of the sea. So how the construction's been made and how the oil rigs been built up. So just want to give an introduction to you. That's what you can see the video. So these are the oil rigs which is in the deep water area. It is almost 1,200 feet. 1,200 feet from the surface of sea level. These are submergible platforms. This is working on the principle of buoyancy force, which we have seen in our basics physics. This is anchors which is secured this platforms. This platform was connected with this anchors in order to get it put it in one place. When the sea is rough, this kind of instability will be there. So that they are putting the anchors in order to get it fixed in one place. This is the living quarters in the platform itself, where the employees are working, can able to stay here, and this is a helicopter pad, and then the people come and work here, and this is an emergency boat. Wherever the emergency comes in this platform, they can able to go. These are the fuels, diesel tanks for using kind of all the electricity purpose. Kind of small generator will be there here. This is a flare gas. This is a seabed. Oil is there with after the plenty of layers. It is not like it is in the surface. So they are drilling now. They are drilling from the drill part, and it is using through the wellhead. From the wellhead, they are drilling into each layer. This is a pressurized water in order to reduce the in order to remove the slurries of this drilling portion. After gets drilled, they are installing a cement steel rod sided by cement, and then the steel rod is inside, because in order to get it fix it permanently. This is a blowout preventer. This is one of the important instrument to get it installed in the oil rigs, because if we don't know the exact pressure of each and every area, we can able to identify which area the oil resources are there using the geological research and development, but we can't able to find how much pressure is exactly there. So when we are drilling, we are obviously we are putting hole into the normal steaming process of this oil storage in the surface of the earth. But now when we are when you are putting hole on it, there is one weakest element which the complete oil trying to come out through that pipeline. So if it is known pressure, then it's okay. We don't know about the pressure, so if it is high pressure being built up, then it may blast the complete area. It may lead into the disaster accident. So that they are putting the blowout preventer in order to protect the pressure, and it will protect until the set point which it is required to handle by the rig. This is called kick. Kick is nothing but the oil is coming out. See, this is the explosion. Without that instrument, um, it's a possibility of hazardness. So that they are installing this one. This is a secondary oil line actually. So once the oil been extracted, it is not it's not having any kind of resources in order to get it stored it or processing it for some further oil and gas products. So they are making another pipeline, which this pipeline will go via this one, and it will go to the surface industries wherever it is there, like in a storage medium, like storage tanks or refinery process. There is a midstream project, that one. This is pumped through the pipeline. See from the all the wellheads, it is connected with the main manifold, and this is a main pipeline. From this pipeline, all the things are getting connected over here, then it is pumped into the mainland via here. This is called the subsea pipelines. See, these are the subsea pipelines map all around the Gulf regions, Gulf of Mexico region. Gulf of Mexico region is nothing but it is in the Atlantic region. It is near to the West Indian area, like West Indies area. Okay. Did you everyone seen that video?
Yes, sir.
Am I audible to? Okay.
Yes,
Okay.
sir.
So
Sir.
okay, madam. Thank you. So that is the thing. Actually, initially we are drilling the oil from the surface area, and we are getting all the crude oils from from that resource, then we are getting stored into the crude storage tanks. There are many kind of tanks are there, so we are stored into the crude storage tank. After that, we are getting processed into the refinery, and we are getting many subsidiary products. Okay, so now we are going to see another one video before starting. This is like, how the byproducts been coming after this refinery after this extraction process. So this is a oil and gas refinery. In oil and gas refinery, distilling is the main process. Distilling is nothing but separation of byproducts from the crude oil. So for that, we are heating the crude, and this crude, it is differing area by area. There's two types of crudes are there. One is sour crude, and another one is sweet crude. The difference is nothing but wherever the H2S content is more in the crude, it is called sour gas, which is like 70 to 85% of sour will be there. So that is called sour crude. Whenever the crude having very less amount of H2S, which is called a sweet crude. Normally in the Gulf region, we having the sour crude, but sweet crude we are getting in Saudi Arabia. I think that is the only area in Gulf, I think so. And after that, we are getting in UK and Peninsula region, like UK Peninsula region and Russian Peninsula region. We are getting the sweet gases and sweet crudes. So just see this. So that is the crude is coming into the refinery, and we are getting heated up. Then there is a desalter is there. So desalter in the sense they will remove the salt content from the crude, and this is a desalter area. So this desalter is a separator. So how it is separating? This is based on the temperatures. So see here, diesel in one platform, and another one is a heavy oil on the one platform, and reduced crude oil on one platform. So based on the temperature and weight of the product, it is getting separated. This is a cracker of heavy oil. Once again, this. Okay, fine. Okay, so this is the only area you need to see here, because there is a distillation process. I will detailing in the forthcoming sessions for this one. I have just cut the video. Okay, let it enter into this industrial overview now. So what all the sectors are in oil and gas industries? In the sectors like instrumentation sectors, we have like oil and gas, power, pharmaceuticals, paper, medical instrumentation, petrochemical industries, manufacturing companies like instruments and control systems. So these are the sectors while effectively using instrumentation and control systems. In this, what are the divisions are there normally? Like, administration, human resource, accounts, information technology, design engineering, construction, site management, project management. So these all are the divisions which comes under each of the sectors. Like oil and gas industries having the same kind of sector with additional some more departments or divisions as well, like power, petrochemical, all the industries having this kind of divisions in order to control and successfully run the sector which way they intended for. And after that, if you see this departments, these all of the departments gets involved to extract the byproducts by each of the sectors. So this is what while we are seeing this is what the reason I have shown the video some of the videos in the initial section why it is. So we just see from outside like okay, this is an oil and gas industries, this is power industry, this is some kind of industries, but it involves many departments and many kind of engineering solutions and kind of many activities been involved in it, and we have potential hazards as well. So what is potential hazard? We can say that in normally in oil and gas industries, the highly poisonous and highly potential is hydrogen sulfide. While we are extracting the oil from the um, rigs, what will happen? Obviously oil we are going to extract, but it is not only oil will come. Some kind of poisonous gas and natural gases, kind of some additional attributes also it will come along with it, so we need to separate it also. um, uh, the H2S thing, how it will affect the person. I want to show you the small video again, then we will completely streamline into our session now. So one of the incident being happened in Abu Dhabi Atco company. It is in 2008, I believe. So see, this is in 2008, which is in Atco. Atco means Abu Dhabi oil oil area. This is like, this is a world class company, but some kind of procedural missing. They have faced very big disaster there. On one good day, people are working normally, and for this is the confined space for this H2S area. This is earlier rig, but um, once it is once it's be extracted, the pumping process and station will be there. This is some kind of pit. So in that pit, some kind of maintenance works to be taken. This supervisor is coming to this technicians, and he is telling to go to attend the small corrective maintenance activity, and they don't have the proper permit for it. Normally, while we are normally what happen when we are go for this kind of maintenance activities, there is a kind of protocols being getting followed, which involves operation department, HSC department, and the technical departments. Now, why we require these kind of departments to be getting involved? um, While we go and walk in the field, we don't know, the technician or foreman doesn't know that which system is operating now and which system is in redundant mode now, which it is under maintenance now. They don't know until or unless informed by the operation team. So this foreman in this fine day, he got an information unofficially, or unofficially from the operation department, like there is one small outage or downtime in the H2S contained area. So he said that we will see whether we can able to solve out. So this foreman, without taking the proper permit from the operation, normally if you're taking the permit, what it will happen, if you are taking the permit, there is such kind of a protocol is to be getting followed, like checking all the people having proper H2S detector or not. They are using personal protective equipment like earplug, helmet, safety shoes, glasses, gloves, and the coveralls. So these are the basic personal protective equipments. In addition to it, if you are entering into the H2S region, they should contain the oxygen bottle as well, like oxygen bottle with the oxygen mask. So these are the things they need to take it. And while we are going to attend one one faulty part in the plant, they will completely isolate it and they will redirect the line into some other line like a bypass line. That is what the thing, while we are constructing or designing the plant, we do main line as well as the bypass line. If any kind of maintenance activities we are going to take out, that time the bypass line will be taken into service and then the main line get isolated in order to facilitate them to get it resolved in a safety manner, as well as giving the enough room of time to get it resolved without hurry. So now what happened here, you can able to see now, without the permit, the crew is going to the working area. See, this is a dangerous zone. This is confined space zone. This pit is already get leaked with H2S. This is filled with H2S now. Unknowingly, these technicians are entering into it, and then they are going to um, rectify some faults. Once the first technician was getting enter into the pit, see what happened. While he completed the job, he's trying to go above. That time he just got fallen because he breathed in enough concentration of H2S. Once he get, he gets collapsed, the team gets panic, and the another technician also coming downside in order to help him to get it out. But unfortunately, he is also fall down. So they both already lost their life. See, another person also, like, he want to help his colleagues, but this hydrogen sulfide H2S gas was cause emergency to them. After such time, you see the person are wearing with the H2S protective gas bottles and all. After that, then only they can able to enter it. Then they took into the emergency hospital, but unfortunately they lost their life. See, when we are going to enter into the hydrogen sulfide or any hazardous area environment, we need to wear this kind of oxygen mask which contains a bottle. This is a bag. We can able to see this kind of bag, but this is not a bag. This is an oxygen cylinder is getting involved in it. So this is the tube which is connected into it. So after this incident, they have made the strict rule in this environment, without permit you should not get it enter into that. But already the procedure is there, but they have avoided that. So that caused a huge problem to them. So what they did wrong in this thing? So we should not take any kind of shortcuts there, and using machines to shift the instruments, and do not panic in the situation. And we have to be more alert. And this HTS is highly poisonous, and we have to work with proper work permit. And we always should wear this hydrogen gas detector. So this is a detector. This will read the hydrogen gas, until 10 ppm. It will detect, but actually I'm sorry that actually up to 10 ppm we can able to survive. Above that we cannot able to survive it. 10 ppm is nothing, but it is very less amount. It is very less amount compared to our carbon dioxide and oxygen, something like that. So this is a HTS monitor we should wear always when the hydrogen gas is present, that this is somewhat heavier, so that we are wearing in the in the upper part of body. Once the HTS is present there, we are entering into the zone. This will get it alert us. So immediately, we need to get out of this region, save ourselves. So this is the mask we should use while we are getting enter into it. Okay, fine. So why I shown this video is there is a potential hazard is involved into the kind of sectors which which involves instrumentation here now. So oil and gas, power, pharmaceutical, and then this kind of natural resource extracting process has highly dangerous things around it. So we need to get it more cautious while we're entering into the operation. So for protecting that one, we are we have to use many kind of instruments and proper pipelines, and then the sufficient amount of electrical power energy to be used in a correct manner, and proper sized mechanical equipments, and properly it has been fine tuned, and the civil structure should be properly built inside the plant, and then the communication facility like telephone and then radio, walkie talkie or wireless communication, it should be properly enhanced with the site into the control room, so that any kind of emergencies we can able to communicate to the people who all are working around the industries. And the loss prevention is a kind of hazard identification team. So they do analyze the process and instrumentation diagram. That is a key role of this plant. I will come next into that slide. They will the loss prevention team will identify where the hazardous area been there. Then they may conduct the hazard operability study and layer of protection areas in order to mitigate the hazardous points in the particular plants. After that, the material control department, what kind of material we should use in this particular in this particular plant, because all plants are not like installed in like same environment. Something like salt laden or seashore area or highly potential and hazardous area, we are installing the plants. So in that time, whatever the material we are using, it should not be get it corroded, or any kind of physical damages should not happen in the in the material due to the practical environment. And so that we are using material control department in order to select the material for each individual components, equipments, instruments, to get their life longer for the plant without any kind of downtime in the plant. Downtime in the sense we don't want to stop the plant at any cost unless or until it is highly hazardous situation being come, like fatality, like loss of life, or environmental get damage, and then asset damage, or these are all the main criteria which we should stop or shut down the plants, unless or until we have to run the plant. This is what the intention of the plants which has been installed. And the quality control team is like whatever the activity is happening inside the plant, they should follow the international standard as well as the country which they are executing the project, that standard, and then the company standard, the particular company which we are working. So these are the three standards each and every department and discipline need to follow, and they have to comply with that specifications. Then they're going to execute it. This kind of checks and quality audits and quality check should be conducted by this quality control material, like a quality control team. And then the planning team is there, so that they will plan the activities of each and individual departments in each way. Without this planning department, we will not organize the team as well as the allocating the work environment to every plans. For example, what happen? Planning team will analyze all the areas. They knows wherever the maintenance activity is going to be taken care. Then they will make the planning schedule accordingly. So because while the instrumentation crew was working in one area, in the same time, if the another team like a electrical or process team or some other team will come, then there is a crowded environment, and then there is um, a loss of concentration also. So they don't want to get it into this kind of hazardous environment and process, so that one team will work in that area and then they leave, and then the next team will come on their activity. So this is what the protocol which we are following in all this kind of process industries. So that is why the planning team is more important for us. So they are doing their activity to protect this one. And where we are using this instrumentation related products, like in the real-time applications, we use in the vehicles are nothing but all the vehicles. We can say that in the road, um, wherever the vehicle we are using the road, and aeroplanes, ships, all are operated by any kind of byproducts of this oil and gas or power industries, kind of things. So and then the infrastructure, commercial and the residential buildings, they nowadays they are using the extra low voltage automations. While we're entering into the room, the light will get automatically on, the fan will switch on. If someone comes in your door, your alarm will your your alarm devices will get automatically operated, and then the CCTV also get on, and then you can able to see in your television in your home itself while you are watching the TV. Fuel gas, naphtha, toluene, and byproducts. The last product of this crude oil is bitumen. Bitumen is nothing but tar, which we are used to make the roads. And the paper industries, normally in daily life we are using the paper, which is also includes instrumentation is a vital role in this departments. And then the medicine and medical equipments preparation, and food industries, cloth industries, cosmetic industries, entertainment village, like we having many fun zone nowadays. In all the areas we are receiving many kind of newly integrated machines are involved to entertain the people, so that all are automated through instrumentation or automation only. So let us go to industrial project overview. So what a project do? This project is involved in all this kind of sectors majorly, but it's depending upon the application, it may get slightly differ, but I am giving you the overall scenario now. So this is an industrial project overview. So how we do a project? What is meant by, first of all, a project? A project is an activity to meet the milestone in coordination of resources or materials or any personnel to ensure that all tasks are completed according to the given timeline. So here milestone we are mentioning. So what is meant by milestone? Milestone is nothing but a project's final product. So for example, we want to build a oil refinery. So making a refinery is a milestone. So in order to make a refinery, we have to have sufficient resources and materials, also the highly skilled personnel in order to execute it. The second thing is project control, is a process of managing projects and is designed to ensure that all necessary steps are taken to complete the project in a timely and effective manner. Project controlling is a team which I have been informed in a earlier session now. So what happen is that project control team will control control each and individual departments in order to execute the project in a timely manner with efficient without any kind of slippages. If any kind of slippages is there, they will make a mitigation plan control, and in order to bring back in order to bring back the situation to the original plan. This is what their role. And then the industrial project flow is a comprehensive approach that includes the planning, execution, and monitoring of projects. Normally, the project flow is much more important to plan the activity. For example, one company is there, they are running with multiple projects. In this condition, we have a specific time limit to execute the project from initial to completion. So accordingly, they need to allocate the manpowers. Then they need to procure the material. The cash flow for the company also been maintained based on this project flow. So the project flow is a very critical role in each kind of projects to get the execute the projects and complete in a project time frame, within a time frame, so that planning, execution, and monitoring of the projects will be handled by project flow departments. Now we come to majorly there are two types of projects in oil and gas or power or petrochemical industries, which we can say that this is greenfield projects and brownfield projects. The greenfield projects is nothing but developing a plant from the scratch. There is nothing will be there. There will be an empty land. From the empty land, we are going to make a project, which is we are going to make make any kind of plant, which is called a greenfield project. Is brownfield project is a second type, which we can say the modifications carried out in the existing operating plant and facility, which the plant is already been running, but the company needs kind of modification or increasing the efficiency, or they want to enhance the operation more. So in this case, they are modifying the existing plant in order to get the best product, so that they are executing these brownfield projects. And then each and every project's having some kind of developments. So there is conceptual. The first one is conceptual design or feasibility study. Initially, the plant is running, or I'm talking about the second one, which is brownfield project. Now, I'm taking as an example. So the plant is running now, and the operation team requires the mandatory change in the plant in order to improve the efficiency as well as the safety of the products. So that time what they do, operation team will inform the operation management in order to update the plant by using this kind of technologies. So that will be useful for operation as well as the byproducts of this company. Then operation team will inform the design team, and design team will conduct the conceptual design or feasibility study. This is nothing but a basic study of the plant. We will give you in detail in the further slides of it. Also, the second point, once the conceptual design or feasibility study is completed, with this reports, front-end engineering design being made. Front-end engineering is a preliminary stage of detailed engineering. Once the first-end engineering design is completed, this will enter into the detailed engineering. Detailed engineering, which I am working now. So this is my area now, detailed engineering. What we do is we do the complete engineering of the total plants, including the process or his supporting process like water or instrument air. The water also is there, mineralized and demineralized water, and coal and fuel gas. These all are our supporting items. So for that also we do the detailed engineering. I will detail this in the further slides. Once the detailed engineering is being completed, then it will enter into the construction or installation phase. The construction or installation is nothing but whatever we do the detailed engineering, with this outcome of this drawing, they do the construction. if any changes in this construction based upon our approved drawings, they do the red markup in the drawing, then it will come to us again after completion of construction. We do analyze this, why the change has been made. If it is not necessary at the time of construction itself, they will ask us for the inquiry, technical queries. Then we will advise them to why not to install or why to install. Then accordingly we will change the drawing, and then we will provide the as built drawing. As built is nothing but whatever is been built in the field, this has to be in the drawing, so that in future they want any kind of modification on the plant, they can use this drawing as a reference. After completion of this construction and installation, it will enter into the commissioning and pre-commissioning stage. Before commissioning, the pre-commissioning will comes into the place. Pre-commission is nothing but ensuring the constructions of equipments and instruments been properly installed and it is ready to get it commissioned. So this is what the pre-check for this commissioning. And commissioning, what is mean by commissioning? We are entering the actual process fluids into the plant in order to get operating. So that is mean commissioning. The initial stage of commissioning, in some of the plants we have faced kind of chemical leakages or process leakages or some kind of blast over there. So this is somewhat practically critical phase of plant getting operational. So once we have get commissioned, this will enter into the maintenance phase. Maintenance is a standard practice which contains preventive maintenance, predictive maintenance, and corrective maintenance. We will discuss in detail in the further slides. So these are the major areas which projects involves in it. So here, if you see this histogram, first of all, when they are going to give a project, they will do research as well as plan. Accordingly, they will design and then they will execute. Then it come to a maintenance stage. The same time, they will recruit the peoples. Also, they will develop the team. Then it comes to maintenance, and this is a complete solution of these projects. You are free to ask the questions wherever you have doubt. This session is nothing but I'm only talking. You also can able to talk. You are free to ask questions at any time. You can interrupt me. Is it clear to anyone? I may continue.
Yes, sir. Yes, sir. Clear, sir. We continue, sir.
Oh, thank you, madam. Okay, fine. So this, so the second phase which you are going is like this detail, whatever I have told here, no, this conceptual design, front-end engineering design, detailed engineering, construction, commissioning, and maintenance. These details we are going to see here now. So in the project's development, we see details of 6 major stages involved to execute the project. The first one is conceptual design and feasibility study. Is nothing but initial phase of design process, which will give an overall function of the system or plant. This report includes executive summary and technical consideration, project schedule, and financial projection. It cannot give you the 100% perfect financial to execute the project, but we can have initial projection on it. So this is what the conceptual design and feasibility study report contains. Based on this report, the team of detail engineering and feed, whoever is doing the detail engineering, they are the people who are going to do the feed also, first end engineering design. So what we do is this feed in the sense first end engineering design. Based on this conceptual design and feasibility report, we do a basic engineering which shall be prepared based on the conceptual design and feasibility study report. In this, various studies will take place to figure out technical issues, rough estimate, investment cost of the project. So once this first end engineering has been completed, this will comes to a detailed engineering phase. This detailed engineering, based on these feed documents, we do the detailed specification, detailed data sheets, drawings, and documents that shall be developed for client review and approval for construction and installation and execution. This drawings and documents is nothing but installation drawing and wiring drawings and how the instruments get hooked up and how the loop has been prepared how to control the plant, and some kind of philosophies needs to be followed for the each and every operation. So we do the control philosophies, cause and effect diagrams, for which cause this effect been happened. So for that we use the cause and effect diagram. So that is one of the very most critical document in our process industries, because in case of any kind of emergency being happened, this plant should shut off in order to protect the people who are working there. They want to save their life. That is the first motto for us. Then we need to save the environment. The third one is we need to save the plant, which is asset, which we put a lot of money to build the plant, as well as the engineers time and valuable knowledge, so that we want to retain it. And then the final one is the project downtime. So if once the explosion had happened, then for bringing back to the original condition, it takes a lot of years or a lot of month to bring back to the original condition. So we need to protect from this kind of disasters, so that we are using the highly protected emergency shutdown system and emergency trip systems, as well as the fire and gas detectors and fire and gas systems to protect the complete plant. So once we made the detailed engineering here, it will come to a construction and installation phase. So based on the detailed engineering documents, plant will be constructed with a technical and HSE crew. HSE is nothing but health, safety and environment queue. Technical team is us, which we seen in the earlier slides. All the departments team is called technical teams. The health, safety, environment team will be always following all of our documents and in the field areas, in order to carry over our activities with proper personal protective equipment and proper work orders, and some of the work orders which needs some supporting protectional guideline also. It is like task risk assessment, and then confined space area, wherever the equipment is installed in the confined space. For entering into the, we seen in that one of the example for this HDS, this is a confined space area. For entering into it, there is a special permit is there called confined space permit. While they taken the permit in that area, during that time they would have not been faced that situation. That is what permit is more important to carry out any kind of activity in the process plants. So these all are the things and protocols to be followed in order to carry the construction and installation activities. Once the construction been done, our quality engineer will come to the site, and he will check the field and each and every instruments with the terminals, impulse lines, cables being pulled, junction box installation, marshalling cabinet installation, everything he will check based on the drawing which design engineering been prepared. So once the both are there, he will sign in the inspection report. That is called RFI. We will make the request for inspection. We will request the inspection team, which is nothing but the quality team, will come into the field, and then they will cross verify with the documents, with the installation in site. After that, they will give a signatory on the document. That is the main document in order to start the pre-commissioning and commissioning activity. Once the pre-commissioning checks has been done successfully, then we will start processing our process fluid into the new plants. Then it has been taken into the stage by stage with appropriate safeguards. The safeguards which I told you just before. Once the plant been commissioned successfully, then we will wait for the process to get it respond for minimum 72 hours with full load of operation. Because if there is any kind of leakages or any kind of abnormal behavior of the plant or any kind of upsets, all the commissioning crew and the design engineering and construction crew is in the plant. So that time we can able to solve it, and we could address the fact of the process. So that is what the team, all the team should be present 72 hours in the plant after gets commissioned. So once it's maximum reached the full load without any kind of blackouts or incidents, then the plant will be handed over to maintenance for their usual maintenance. Or if we find any kinds of stoppage or breakdown or any kind of abnormal operation, so we will address it and we will rectify it, and then we will hand over to the maintenance team. This is what normally the plant projects will get developed and then gets run for many years. So these are the basic overview I want to give to the attendees. Now we enter into the basics of instrumentation. Instrumentation is a process of measuring and controlling the physical or electrical systems. It is used to measure and monitor, finally control the parameters such as flow, level, temperature, pressure, vibration, axial or radial displacement, gas detection, flame detection, current, voltage, etc. For measuring signals, it involves a variety of technologies like sensors, actuators, and controllers to integrate with the control systems. It is also essential to ensure the safety and efficiency of the overall system. So here we are seeing the instrumentation, how it will be. So majorly in instrumentation we are focusing on to measure the line pressure, the tank level, and then the tank or line temperature, and then the line flow, like line in the sense I mean pipeline flow. So for measuring this kind of process flow or process medium, we need such kind of advanced instruments to be taken in place in order to know the actual value to control the plant with efficient manner and also safety. So here if you see this one, this is a pressure transmitter. This is a pressure transmitter which can sense the pressure in the particular line. Then it will give the signal via junction box and marshalling cabinet to the system cabinets into the operator control room. They can able to monitor. If any kind of malfunctions in the pressure transmitter, it will be noticed by an operator, because since he is monitoring in his control station, so he will inform the maintenance team. So maintenance team will come and take the permit and go to the field and will check if it is all the things are okay, like there is no problem in the field. He will inform his engineer, and his engineer will take sustainable action in the control system side and where the problem is exactly taken, and he will resolve it accordingly. So like same wise, this is a temperature transmitter. The temperature transmitter having two types normally, like we can say that thermocouple principle operated and then RTD operated, which is nothing but a resistance temperature detector. So here if you go for high temperature range, like more than 350 or 400 degrees centigrade, like more than 300 until 1500 1600 degrees centigrade, if you want to get it measure it, we use thermocouple. If you want like small kind of temperature we are going to measure it, so we use resistant temperature detector, which is platinum 100. Normally we use, this is what the traditional method of instrument measure for the temperature. So what is thermowell here? This thermowell is a part which been installed inside the pipeline. Because for example, if you see here, for the pressure, if you are going to monitor, we are going to put one isolation valve. From the isolation valve, you can able to take the impulse line. That impulse line going to be connected in the pressure transmitter. So we can able to measure the pressure outside of process line itself, but for the temperature, you need to measure the exact temperature of the process line which it is going fluid. So here if you see, this is a process line we can assume. So here we having a mechanical flange over there. In that flange, this thermowell been installed. This thermowell is penetrated into it into the process line, which is like 3/4. If the pipeline is 1 inch, so 3/4 of this length, the thermowell needs to be installed in order to sense the proper temperature, and it will give the exact reading in order to further control the process medium. So this is what a general outage of temperature measurement. This is a level measurement. This is guided wave radar technologies using this level transmitter. Normally we have many type of level transmitters are there. Like principally we can say that guided wave radar, ultrasonic wave radar, ultrasonic level transmitter, and then buoyancy force principle used one. So nowadays we are going ahead with guided wave radar, which is easy to install, as well as it has less amount of maintenance, and it gives measurable range of wider medium, so that we are going ahead with guided wave radar. In some of the cases we are using the ultrasonic level transmitter, which is having the steam applications or sludge applications, any kind of pit which is filled with dirty fluids. So for that kind of applications, we are using the ultrasonic level transmitters. This is flow measurement. Flow measurement is like two types of flow measurement we have, which is mass flow, and then another one is mass flow measurement, another one is variable measurements. So here if we go to this mass measurements, there is many types of flow transmitters are there: Coriolis and vortex flow transmitters, vortex, Coriolis, differential pressure type, and electromagnetic type, ultrasonic type, target flow meter type, Anubar. So there is plenty of type of flow transmitters are there. We will select the transmitter based on the process fluid, as well as which kind of flow important for them. For example, we can say we are sending this product to some other plant. Like from our plant we are sending into another plant. So we have to monitor the flow, as well as we have to have a proper cubic meter or meter cube per hour, how much we are giving in a day. So that calculation is important to make money on it. So in that kind of thing, we use custody and non-custody kind of flow transmitter also. Here we have shown some of the basic flow transmitters here. So these all are the four major types of transmitters which we used in an instrumentation. And just giving an overall view. So if we go into detail, there is plenty of things with specifications and data sheet. So with this presentation, we'll have an overall look over it. So these all are the things which can able to read in the system. So these all are analog inputs for us. So what control valve does? Based on this analog inputs, we have set limits and set points in our control system. For example, in one line, we want to send the pressure at 6 bar, which is bar is nothing but kg per centimeter squared. So 6 kg if you want to send in one line, if we have put we have do the study in engineering like alarm rationalization study, and then alarm set points, alarm and trip set points as well in some cases, which is more hazardous fluid is passing over it. In order to protect the plant, we use a tripping system also here. So if 6 bar we are going to operate, so we put like if it reaches 5.5 bar, then we have to give an alarm in the operator room, which is called um, alarm. Alarm area, we should get the notification like this pressure transmitter is sensing a low alarm in this particular process, please look into it. The same case is for high, low and high. Like if it is 6 bar we need, then low is 5.5 and high is 6.5, and then low is 5 and high is 7. So why we are putting this? So I'm just giving an example on it, but this is not exact value. We do detail engineering on which process what kind of alarms been set. There is a calculation been behind that, so we do that accordingly, we'll set. But as a overall pictorial representation point of view, this kind of if process value is 6, then low alarm is 5.5 and 6.5, and then the trip value is 5 and 7. Based on that, our control valve will get operated, because this is a final control element for us. This is a sensor, these all are sensors for us, which will give an input. After that, based on the input, our controller will study, it will matches with the set point, which the controller's job. The controller, what it does, it will sense the real-time process value with the set point. If the set point is matching, then the control valve is in the exact position. It will not get it respond. The process will flow accordingly. And then if you see any kind of variations in that, then it creates an error value. That error will be mitigated through a disturbance point. That disturbance point will give the error mitigation value. That value will go to the control valve. Accordingly, control valve will act. If the pressure is high or the flow is high, then the valve will close. If the pressure is low and then flow is low, and then the valve will open in order to match the set point of this process line. So this is the basic things of this instrumentation. This will work accordingly. So here we have a type of signals. So what type of signals we have? We have basically analog and digital. We have two types of signals, which is like analog instrumentation is used to measure and controlling the physical or electrical system, which is analog input and output. So which this one we know that this is a transmitter which is giving the signal to the control room. This is analog input. How we said that we consider control system as a master. For control system, if he receiving the signal, then it means it is input. If control system is giving the signal, mean output. So this is what the funda behind that. So now we can able to understand this one. If this transmitter is giving the signal to the control system, which is analog input, the control system is giving the signal to the field control valve, which is analog output. The same way applicable for digital as well. This is a limit switch in the field. This limit switch is operating whether the valve is open or closed, or any solenoid valve is open or closed. In this case, this will give a 0 and 1 value to the distributed control system. This control system will analyze and it will tell yes, the valve is get open. So this is a digital input for him. And then for operating the solenoid operate valves, or any kind of sounder or beacon, in case of any kind of emergency in the plant, our fire and gas detectors, flame detector or any combustible gas or toxic gas detectors or hydrogen gas detectors, This kind of detector, if they sense the signal, this will give an analog indication to the plant, which will tell this is above the alarm limit. So we need to actuate the siren and beacon in the plant in order to evacuate all the people from there. So that kind of operation, we are going to operate the sounder or beacon. In this case, the the DCS system will give the signal to the beacon or sounder. So in this case, that is a digital output, which is 24-volt DC, which is going to give. So this is the funda behind that. So this is a process thing actually. So why it is getting involved into it? So this is a sensor which we seen here now. This is a sensor here. This is a sensor. This is a final control element. We can say that. From the sensor, this is processing, and which is going to the controller. Controller will decide, then it come to the final control element, which the control valve will open or close, and accordingly it will maintain the process. This is a closed loop controller. So this is what the funda behind the instrumentation loop is getting operating. Okay. Madam, I'm continuing now. So, do you want to take a break, or we can continue?
Oh, no, sir. Continue, sir. The session is from
Okay.
10 to 12. So you continue, sir.
Yeah. Okay.
Okay, sir.
Okay. So we are now 11:20.
11:20, sir.
First down. Okay, it's 11:20 in India. Okay, fine, madam. Okay, so I will progress accordingly. Actually, I have some more slides. Is it okay to proceed for some more time, or?
Yes, sir. You proceed, sir.
Okay, madam. Thank you.
Okay.
Okay. So here, if you are seeing these slides, these all are the link cabinet which is connected to the DCS or PLC system cabinet, and after that it is connected into the process control systems. So these are the main view of this control system basic working practice. So how it is been practically installed in the plant, we can able to see here. This is the pressure transmitter which is installed in the plant, which is mounted on the mounting plates, and here the impulse line which is coming from the process line, which is connected through an impulse line to the transmitter here. So from this transmitter, this cable is going. Now this cable is connected to here to this junction box. This junction box is this one, field junction box. This instrument connected to field junction box. After that, it is going to the marshalling cabinet. This marshalling cabinet is this. This is the one. We have seen many kind of marshalling cabinet because we 100 to 600 instrument signal. We need to take this kind of same philosophy from here to junction box, from junction box to marshalling cabinet, so that the marshalling cabinet room is this much big. From this marshalling cabinet, this is coming into the system cabinet, which having all the controllers of this distributed control system. From here, it is connected to the operating control room area. So this is our operating control room environment, which the operator will sit here, and then he will monitor all the area of the plant, and he can come to know that any kind of alarm or any process upset been happen, and then he can able to monitor from these monitors. So that we have facilitated with this kind of facilities here in order to operate safely and effectively here. So this is the area. So this is the process area in the field. This is a process area. We can say this is a field area. These both are installed in the field. These both are this marshalling cabinet and then the system cabinet are installed in the control room itself. These both are installed in control room. This is an operator room, which is nothing but this one. This is the overall control system installation been happen. So this is an architecture for the same thing. So we see this, all the instruments are installed in in the field bus area, and after that it is connected to the control system. Controllers, all the controllers being installed in the control room area. After that it is connected to our distributed control system. This is an architecture behind that. Now here, when we come to an advantages and limitations in the instrumentation and control system, when we are installing an instrumentation, we have to see advantage and then the limitation. Accordingly, we need to choose it for each and every individual applications. Now, for this instruments, we can see it is reliable and cost effective and easy to install and maintain. This is all are the thing which we are following presently, and it is compatible with the existing systems and can be easily integrated to the third-party systems. Third-party system is nothing but PLC system, we can say. For DCS system, PLC is a third-party system. How we are saying that if the network been connected here, see here, these all are the same network. If this distributed control systems and emergency shutdown system and fire and gas system, if all are in the same network and the same topology or same bus area, then it is called as a mother controller, which is their own path passage they are been installed. If it is installed in separately for that any third party configuration system, like for or power plant, we need some water resources like steam resources, so that we use boilers. For controlling the boilers, we use PLC. In this case, this PLC also need to be communicated to our DCS, which is via third-party communication, which is TCP/IP protocol, Modbus communications, or fiber optic communication. We are going to use it. So this is what it means. And then highly flexible and can be customized to meet the specific needs of the application. So it is highly flexible. We can use whatever the platform it is. So the customization is easy in it. Here I told that the existing system is nothing but the plant is already been installed, and then we are going to connect the new PLC into it, which is like the brownfield operation. That is what existing system means. And then the limitations. What are the limitations being beyond that here? They are not suitable for the applications which requires remote monitoring control. For example, the plant is running there. We are sitting in a corporate office or in the home. We need to monitor it. No, it's not possible with present days of instrumentation. And cloud making and cyber security is complexity. Cloud mapping and cyber security compatibility is a lag in technology. Yes, obviously, the present technology is whatever we are getting the instrumentation now, that is having the provision of cloud mapping and cyber security which the client wants. So in the past days, in the ancient days, we don't have this kind of technologies, so that is a limitation for us. Difficulties in integration with the new applications which requires version or firmware alignment. Yes, nowadays whatever the systems are coming with us, that having a unique resolution and a unique version and firmware alignment, which is not been aligned in the earlier instrument, so that is having kind of integrity issue with us, and limited in their ability to integrate with other systems and devices with their compatibility with the newer technologies. This is what we told. Okay, so what is the trend in instrumentation? What we are what is the trend and what is the future of it? Now we moving towards a digital system, and it is more reliable and easier to maintain, and their analog counterparts, we can say that. What is my digital system in the sense? Previously, we have told that we are using kind of instruments which is connecting to junction box, Marshall cabinet, and then it is coming to our control systems. But these all are wireless devices which can able to communicate wirelessly without installation of any kind of JBs, Marshall cabinet. It is directly communicating with any kind of a signal repeater from the field instrument to signal repeater to the DCS, distributed control system, directly. But these are the things is not in a full effective manner nowadays, but it is available in market, but we are not using it for this kind of oil and gas industries, because the consequences of the hazardness now, based on the videos which we have seen before, so that we are not taking a risk on it unless or until it gets proven into the market with the highest standards of safety and protections. They also provide greater flexibility in terms of programming and data collections. In this kind of remote devices, we can able to store it in the cloud mapping, and it can able to communicate via the wireless communication. This is what it is mean. So wireless communication networks allows the greater flexibility in terms of installation and maintenance. So once been installed here, we no need to come and do maintenance here. If any kind of problems, we can able to understand via using soft tablets or any kind of wireless technologies like mobile phone. We can able to control it with that kind of mobiles and all, mobile phones and all. Not we are using like a common mobiles. It is not like that. This is like an explosion proof mobiles which is specially designed for oil and gas, which we can able to monitor from there, but it is not effectively coming to the installation phase as we discussed earlier. Finally, we use of cloud mapping and the cloud computing is become more prevalent in instrumentation and control systems, allowing more efficient data analysis and control. This is what now the data has been stored using cloud mapping, this kind of things, but it is not properly been evolved it. But in future, obviously, this is a trend in it. Here, for the design phase, as we discussed earlier, feed first-hand engineering design and detailed engineering design. In this stage, we are using this kind of Navisworks 3D modelers. So what is it does? When we are designing a plant, we have to know the virtual implementation with the correct size, and then what are all the areas which we are going to cover, what are the disciplines been involved, how their instrument should be. So this is what nowadays this industrial internet of things devices allow for remote monitoring and control for a process and machines. What it does, from this we can able to monitoring, and then we can able to control the instrument or the process or machines. And then this technology brings you to improve the efficiency in manufacturing process, reduce cost, and increased safety. Additionally, advances in artificial intelligence and machine learnings are enabling more sophisticated control systems that can make decisions and respond to the changes in real time. This is what artificial intelligence does. Artificial intelligence in our in instrumentation field, like the basic is artificial intelligence with cloud mapping and then wireless communication. That is base. Depending upon the applications, wherever we are using, you can using in any kind of manufacturing industries like car manufacturing or mobile phone manufacturing or any kind of industrial manufacturing or medical equipments, or our oil and gas instruments, whatever it is, based on the applicants, it is little bit getting changing, but the base is same. Finally, we use the augmented reality and virtual reality is likely to become more prevalent in instrumentation and control system. This will allow for more intuitive and interactive interfaces, as well as the ability to visualize and interact with data in virtual environment using Navis 3D. When we are designing the plant, before this technology comes, we know the sizes of the plant, we know the sizes of equipment, the area. Based on that, we will assume it, we will make the drawings accordingly with the correct dimensional, accordingly we place it. But nowadays we having the tool and technologies. Based on the technology, we will virtually make the plant. We do analyze during the time of detail engineering itself, so that we can avoid many kind of doubts. And when we are seeing in the drawing and when we are seeing virtually, there is a big difference in it. So that all the disciplines are gathered in our meeting room. Accordingly, we make 30% of this review, like a design stage. If you consider one project is going to happen in 0 to 100%, while we are executing the project up to 30%, we do this review. 30% review, what it will do, it will conclude the area building and which plant is going to which area, and then the area allocation will be get confirmed on that place. For example, if I say we will take our college as an example. Our AVC college is there, so we consider our complete compound as a plant. In that plant, we will come to know that which is administration block, which is study like classrooms, and where is the library is going to come, where is the hostels going to be placed, and these all are the things getting finalized in the 30% review of the 30% review. While we are doing the 60% review, we go more in detail. So in administration building, how many blocks should come and what all the rooms are going to be made. Likewise, in our classrooms, like for example, if we consider computer science department, there are 4 years are there in our college. Each year we need to consider each classes, so 4 rooms to be considered. So likewise, we need to get it detailed in the engineering phase of view, which is being confirmed in the 60% review. And then when it comes to a 90% review, the project been almost been like executed, like it is designed. After getting designed, if we have any kind of minor corrections, or we need to ensure that whether the plant or the infrastructure been built it up based on our engineering, detailed engineering. So for that insurance, we are making 90% review also. For that review kind of meetings, this virtual or virtual reality is much helpful for us, so that this kind of trends always already available in our market. We are using it nowadays for our designing, but still using the artificial intelligence and then the virtual reality, it is more comprehensive, and it is more easier to approach, and then we can add many like values in it. So this is what the trends is coming into instrumentation now. Now we see this artificial intelligence. While we are seeing this plant, we see these all are the things are installed in the mid-sea area. So for that, if you have if you want to send any kind of the spare parts, or any kind of sudden failures are happening in any kind of instrument, you want to send it from the stores to the plant. So we are using nowadays, we are using the delivery drones. So this delivery drone, what it will do, it will take the equipment or instrument which it can able to carry. So if it is sufficient for that, so we use this drone, and then it will be delivered inside the rig area, so that they are using they can install the spare parts in a timely manner in order to avoid the down times, as well as the increasing the efficiency of the plant as well. Also the surveillance drones. So the drones are getting survived. It can be able to monitor, or as well as see the physical environment, how the sea is like. Now it is rough sea is there, or calm sea is there, or any kind of abnormalities in this area, or any kind of some vulnerabilities happening near to the area with some kind of disturbances and all. So it can be able to monitor with the surveillance drones. And integrated operation centers, it is like all the centers, while we are controlling the plants via our DCS or control system. So this is what it is mean. And a real-time request oil field services, this is if it is in the field, actually for this area we are putting the pipeline through the subsea pipeline, it is going to the field. So this is what it mean. We are using the 3D printers also. While we are seeing this kind of virtual realities, nowadays we are able to make, and then we can print the 3D view of this plant, and then it is easier to get it explored into the team or any kind of discussions. Okay, now we have almost covered the instrumentation and the basic engineering practices, and now we go to a small industrial walk with the sectors of oil and gas, power, pharmaceutical, manufacturing, and aircraft engineering. So while we go to the power plant industries, oil and gas industries is composed to upstream, midstream, and downstream. There are three streams involved into the operation. This is what upstream, which the rig been involved here, so that this is upstream. And then the midstream is refinery area, which you've been already also been seen in the distillation column. Now the downstream is, you know, that these all the petrol pumps which
Excuse me, can I-
which are available in our market.
Excuse me, can I
Yes, sir.
interrupt?
Yeah.
I am
Yes, yes,
Kalyan
please,
Sundaram,
please.
Associate Professor from Parajita Ministry of Technology.
Okay.
Mr. Sarbalan, you have been given a extremely very good lecture on control and instrumentations, and really very
Thank you,
interesting
sir.
and very informative. But my point is,
Thank you, sir.
when there are a flow transmitter in the process line, when you try to mount over, and if
Sir, you are
there
not
is
audible.
I'm not able to audible. Now are you able to listen?
Yes, sir.
Are you able to hear?
I will answer. I will. Yes, yes, yes. No, you are.
See, if there is any
Yes,
fault
sir.
in the flow meter, are you getting me?
Yes, sir. Please go ahead. Go ahead.
So, if there is any fault in the flow meter, which is the process line,
Okay.
what you will try to do now? Are you have to stop the process, or is there any way to operate the system? Are you getting
Okay.
my question?
Yes, sir. Yes,
Suppose
sir.
you are
Yes, sir.
using a
I
flow
got it.
transmitter in the process line, suddenly there is a
Yeah.
fault in the process flow meter.
Yeah. Yeah.
What is the operations we supposed to suggest?
Yes, sir. I appreciate this question. This is very innovative question, sir. Actually, while we are installing the flow transmitter in
Yeah,
the field, checking the process is ongoing, but the transmitter
yeah,
is mounted on the transmitter is mounted on top of it. You can see.
yeah. I know that. But you
Yes,
can
yes, sir.
you say
So,
that if there is any fault has come, what is alternative steps to be forward?
yes, I will come to that one. So now here, come to answering your question. So this is a flow transmitter flanges which is installed on the line. So the line
Right.
is not getting interrupted on in any point of view. If you are getting any problem with this electronic devices, so what we do is our distributed control system will come to know that this transmitter having some issues like electronically or like the problem in the process or any kind of thing. So we will inspect this instrument first, and after that whether anything gets failure here, we do isolate this transmitter, because this is not the only transmitter which we install in that particular line. We have redundant transmitter also. So if one transmitter gets failed, we do monitor or control from the another flow transmitter. By the way, we do analyze the problem of its flow transmitter in the field as well as in the control system point of view. And then if it is
You mean to say that if there is in the flow transmitter, you will have a redundant, you will have a parallel line.
yes, obviously we have a bypass
See,
line.
there are
This
many
kind
flow transmitter may be used in this process, but in the
correct.
particular flow transmitter is failing. And because a single line diagram, you are not able to show any kind of a bypassing arrangement, a manual arrangement. In case the flow transmitter is failure, even if you wanted to get to replace them up, or you attend to the fault and get rectified for further process, in between, in meantime, the entire process will be getting spoiled. Until otherwise, if you do not have a bypass system, bypassing
Yes, that's
system,
what I'm.
either a
Yeah, that's
manual or you can have your own same instruments. Suddenly you can bypass the system and you can operate it, and then you can replace these equipment and you will try to get repaired. Is it right?
yes, sir. You are right. But the thing is, it is depends upon the system to system. Let me
Agreed.
let me share one screen to you.
Yeah.
Okay. So if you see, this is the
Sir, okay, I do understand. When you, as you rightly
yeah,
pointed out, the redundant needs, there itself your answer is right. But that is
yeah.
what I wanted to envisage is. See, basically,
Okay.
everywhere you cannot put the redundant system. It's very costly.
See,
But
yes,
for
sir.
which,
Yes, sir.
manual system we should have everywhere, wherever wherever the systems are there, there should be a manual bypass system must be made available in order to attend in order to attend the problems. Okay, but there are
Yes, yes.
many instruments which you are envisaging in the pipeline, either pressure transmitter or a temperature transmitter or any other transmitters.
Okay.
And what is the protection class? Because it is in a completely in a hazardous location, explosive, fire hazardous. And
Yeah.
what is the protection class you are envisaging for those equipments?
Sir, actually attack certification is there, and then EXD, EXI, EXE, like flame protection, intrinsic safe and extra intrinsic safe, this kind of protection based on the applications we are getting using. For example, if it is exposed to an the atmosphere which is the highly explored hazardous area, we do with EXD with EXI with intrinsic safe, because we want to
Okay,
protect the
you
electronics.
have that IP67 or I still more classes
yeah.
are envisaged, right?
Yeah,
One
yeah,
more
that is
thing, one
that
more
is
thing,
ingress protection, you
gentlemen,
mean?
right, right. You see,
Sir, you mean?
there are some of the instruments which is getting mounted in the oil and rigs or oil and gas plant, and especially you do like to use an acid proof, like a flame proof or explosion proof. If the instruments
Yeah.
comes under the acid proof,
Actually, sir, that is explosion proof is the one. There is no acid proof. We can say that NAS compliance, which is corrosion compliance instruments, which
in one
is
of the company where we were informed that saying that there are many instruments getting spoiled because there is an acid proof. There is an acid residue which will try to kill the equipment very fastly. But still, acid proof is yet to be get developed. But as far as
Sir.
today is concerned, we have a flame proof and the explosion proof. The acid proof is yet to come forward.
Sir, actually,
Okay, thank you. Carry on.
Please. Yes, sir. Yes, sir. Yes, sir. Sir, actually, I want to interrupt in one point of view. Actually, sir, acid proof in the sense, acid spilling over is present in the plant. That is what you mean, right? When the acid is getting spilled on top of the instrument is getting failure. You mean, right?
Yeah.
Okay, sir. Okay, so that itself a big hazard. We should not
big hazardous.
drop
Big
any kind of acid into the plant. That is a big hazard. That is what we have protected the line itself. We have enough layers on it in order to protect the acid leakage itself. So the acid should not be getting fallen over.
Acid
If
in the
it is
sense
in
which
case
I am
gets
trying to
fall down.
point out. No, once again, the oil and rigs, when you try to extract oil from the surface, a sulfur is one of the most dangerous element that sulfur, if it exceeds certain amount, which immediately will try to invite the acid.
Yes, hydrogen sulfide, yes.
Right, please carry on. I am sorry for the interference, and you were really very
No problem.
extraordinary. Very good. Very brilliantly you answered.
No problem, sir. Thank you so much, sir. You are most welcome. Thank you so much, sir. Actually, we need this kind of questions to be get it interrupted so that I am also be active and then the people also get it active.
Thank you. No, I worked in 40 years in BHEL, the power plant. So where I was exposed in all kind of problems. Okay, thank you. Thank you.
Very good, sir. Okay. Nice to know, sir. Nice to know. Thank you so much. We will come to your area also next.
Yeah, please do. Please do.
Okay, sir.
Go ahead.
So come to the point here. So so we having an upstream operation, midstream operations, and downstream operation. We having an upstream operations like all the rigs, and then midstream operations in the refineries, and the downstream operations. We know that these all are the downstream operations. We know all the petroleum products being sold in the petroleum pumps. So upstream, what it will do, the exploration and extraction of oil and gas is a first step in the oil and gas industry. Exploration involves the use of geological and geophysical techniques to identify the potential oil and gas reserves. Wherever the oil is contaminated in the surface of the earth, through the geological and geophysical techniques, we can able to identify it in order to drill the particular portion in order to extract it. Once the potential reserves is identified, then extraction process begins. This involves drilling wells and using specialized equipments to extract the oil and gas from the ground. This is the upstream operations. Regarding the midstream operations, once the oil and gas been extracted, it must be transported and stored. After that, this is done through a variety of methods, including pipelines, tankers, and rail cars. Through this, any of this mode, it can be transmitted into the storage tank. After that, it is treated in the refining area, which is our midstream area. After that, in this midstream area, we having a refining process. The refining process involves the use of specialized equipment and processes to convert the raw oil and gas into usable products like jet oil, petrol, diesel, kerosene, LPG, paraffin, reduced crude oil, etc. These all are the byproducts when we are getting heating and refining the crude oil. And these products are spread from crude oil while heating the various temperatures. Marketing involves the sale and distribution of this usable product to consumers. Okay, now, I'm sorry. So this is the one. So here the crude is, we will see the process flow diagram of crude oil distillation, how it going to. This crude is entering into the preheating exchangers. After that, it is going to the desalter, which will remove the sour waters. After that, it is entered into the flash drum. Then it is getting fired up. Once it reaches the prominent temperature of 750 degree Fahrenheit is nothing but 400 degree centigrade, which is entering into the atmospheric distillation column, which having the ceramic plates over here, which is getting sprayed over here. This is splashed here. So once it is getting splashed, based on the weight of the product, and then based on the temperature classes, this is getting segregated to the various products. Here, if it is 70 degree Fahrenheit, is nothing but 20 degree centigrade. The gas which has been contained here, which is going out, and then it is stored in the bottle on of natural gases. And 350 degree Fahrenheit is nothing but 150 degree centigrade. It will extract the naphtha, and the 390 degree Fahrenheit is nothing but 200 degree centigrade, which the kerosene will get extracted. And after that, gas oils on 300 degrees centigrade, and then lubricants oils like 450 degrees centigrade, and this is 500 degrees centigrade. The fuel oil gets separated from this atmospheric column. This is the one of a heart of the refinery process. This was, we can say that. So let us go into the power industries. In the power industries, which is divided into the three main sectors, like generation, transmission, and distribution. Here, if you see the generation, this is the plant which is called a generation plant of electricity, and through the transformers, it is connected to the transmitter lines. From the transmitter line, it is connecting to the local transformers, and from this, it is going to through the distribution lines, it is going to the consumers like residential or any kind of business industries. They're going to use it. So now, what generation is doing? Production of electricity from coal, LNG, water, wind, or solar, etc. Whatever the resources we are using, based on that we are getting generated the power. The transmission is nothing but the transporting the electricity from power plant to substation. We are transporting all the electricities from the power plant to substation via this transmission lines, which is having the 33 kV or 415 kV, or depends upon the distance which you are going to send. We will increase the potential of this voltage, and then we will send the electricity to the distribution, delivery of electricity from substation to the customer or consumer. This is for the three steps which is mainly involved in power industries. You still power generation. Power generation units have few major areas, which is boiler area, turbine area, generator area, alternator area, fuel handling unit, and then water handling unit. This boiler area, what it will do, it will boil the water in order to get it to the steam. That steam is injected into turbine. The turbine will rotate. Turbine is connected to the generator in a same shaft. That generator is connected to the alternator, and that if the turbine gets rotated, simultaneously generator will rotate, then alternator will rotate. What alternator will do, it will cut the magnetic flux, and the flux will generate is the voltage. So that is been that is a funda behind that. The turbine is getting rotated. Based on that, generator will rotate. After that, through alternator, the power is getting generated and it will fit the transmission line. It's going to the substation and going to the customer. And after that, here the fuel handling unit. The fuel handling unit, if it is a coal plant, the coal can be handled via fuel handling unit. If it is a natural gas, so the compressor should be there in the plant. So from the, for example, in the India, GAIL is there, Gas Authority of India Limited. They are the natural gas providers to the consumers. So they will send the natural gas with a nominal pressure like 7 bars or 7 kgs, like that. They will send it to the power plant. The power plant having the multiple stage of compressor, they will compress the they will compress the gas which it is required for the plant to get it operated. So for the natural gas plant and all, what it will do, there is IGV is there, inlet guide van in the turbine itself. So what it does, for igniting the the flame, we need 3 resources. One is air, fuel and spark. The fuel is the the natural gas, atmospheric air will be there, and then the spark will be provided in IGV. So based on that, it will rotate. That heat energy will rotate the generator. Based on that, the alternator, and then the same philosophy will be get it followed. So, and then the hydro also same funda. The water will get it into the turbine, and then the turbine will go to rotate. And the wind is you have seen in the many places in the movies and all, we can able to see that. Which is in the south side, it is more famous. The wind is the big, some kind of blades being installed in the generator motor itself, with the tallest tower and all. So yes, we can understand that minimum amount of power can be generated in it, but continuous generation is present in that. And then the solar, nowadays it is a booming sector. Many of the industries are converting their power business into the solar system. Presently, Adani Power Limited, for example, Adani Power Limited installed in Madurai, Kamudi, around Madurai, near to Madurai and Kamudi area. That is world's largest solar power plant in a single unit. That is around 460 megawatt, I think so. Actually, I was started my career in Adani Power Limited as a graduate engineer trainee. This for just an information. And then for power generation, here, if you can able to see here, the power generation is generated based upon this one. And after that, burning of fuels such as coal, oil and LNG, liquefied natural gas, fires a boiler to generate high temperature and high pressure steam. It will generate. This steam is used to drive a steam turbine. The generator attached to the steam turbine generates an electricity. So the generator is attached to the steam turbine, which will generate the electricity based on the principle which we told you earlier. The low pressure exhaust from the turbine generates a steam condenser, where it be cooled it and produce a hot condensate, which is recycled to the heating process and generate more high pressure. This point I will explain you here. So that, see here, this is a this is a river, this is a coal. This is for the coal fired power plant. So here, if the coal is putting into the boil furnace, and then this is getting heated up. So actually here 2 types of water. This river water is used for condensate cooling, and this boiler water used as a mineralized water. This both waters are different. So inside the tubes we having the demineralized water. This water is absorbing the heat, and then the water is converted into steam. That steam is injected into the turbine. The turbine will rotate based this steam turbine. This having many stages. High pressure turbine, medium pressure turbine, low pressure turbine. These all the stages we gone through, and then this demineralized water will come back again, and then is cooled up in the condenser area. This condenser area cooled by this river water. This is a separate circuit. This circuit will come like this, and it will come to the condenser area, and then it will cools the steam, and it will come go back to the river. But this process, this water will come to the boiler and in heated up, and it gets steamed. Then it comes to condenser, again water, then again steam. So this water cycle is different. Then alternator, and then this going to the transmission line. So this is one circuit. So here the power transmission, the transmission line is a network of lines and substation. These lines are made up of high voltage power lines which can transmit electricity over the long distance like 500 or 900 kilometers based upon the kVs which you have been get it produced or transmitting. Substations are used to reduce the voltage of the electricity, making it suitable to use for the households and business, because whatever the voltage we are sending in the transmission, you cannot able to use the same voltage in your household items, because your household items are maximum 24 voltage or 110 voltage operatable, so we cannot send that much huge power to our house. So that we are using the substations, and then we are reducing voltage, and then we are sending into the home or any kind of business. And power transmitter have a major source of energy loss and significant amount of energy loss in the transmission process itself. This have a main grid circuit. I'll come in the distribution area now. So now the power industry improving the efficiency of power transmission using the new technology such as high voltage direct current (HVDC). High voltage direct current is a transmission which is 600 kV kind of high sensitive lines. So come to a power distribution area. The power distribution is a process of delivering electricity from the substation to the consumer. Here, if the power being getting generated, this is sent to the transmission line. The transmission line is connected to a state grid. That state grid is each and every state having a grid. It is like a physical connection. So that grid line is connected to the center. So the state grid, if one power plant is there, the power plant will produce the power and it will give the state grid. The state grid, each state grid will be controlled by central state grid. That central state grid will distribute the power plants all over the country. If wherever the power plant blackout is there, this is easier to be get it connected inside the grid line, and then the power will be getting supplied to the households or business without any interruption. This is what the funda behind it. So that it has been divided into state grid and central grids. For example, in the year of 2010 to 2014, we Tamil Nadu having the contract with the Adani Power Limited in Gujarat. I was working in that time in there. At that time we have manufactured we have produced the power, and that power was distributed to Chennai city one time. But it is connected through the same philosophy like state grid and then central grid. We are giving power to the Maharashtra area, and Maharashtra will give to the like Karnataka or whoever it is, and after that it will coming to the Tamil Nadu state. So this is what the state all the grids are linked with. Okay, and then come to the pharmaceutical industries. It is in highly regulated and global business that develops, manufacturers, markets, and medications used to treat and prevent the disease. Now here the research and development is a main role here. Actually, here in this pharmaceutical industry we have three sections. One is research and development, another one is manufacturing, another one is distribution. For the research and development, they do innovation, trials, and approvals. Once it has been done, then it comes to a manufacturing process. Manufacturing process having two sets of things. One is integrated continuous manufacturing, another one is batch manufacturing process. The final one is distribution. We know the delivery of this has been overwritten. So the distribution of this pharmaceutical products to the peoples. Then the research and development, what it is, this process involves extensive research, clinic trials, and then regulatory approval. Once this has been regulatory approved, it taken case even decades and develop for one drug for preparing one drug, it needs extensive research and massive clinic trials, and then it goes under the regulatory approval, then it gets approved. Then only it will come to a market as a tablet or whatever it is. Now, here the pharmaceutical companies must invest large amount of money in research and development, and only a small percentage of drugs have come into the market. The process, this process is highly expensive, and then the success rate is very, very low. However, when it gets successful, it will rewards can be enormous. For example, now we see in the COVID-19 pandemic over the world here. In that time, everybody is researching and they do the clinic trials, and somebody only gets succeed, and then that injection was spreaded over all over the world and they got succeeded. So that is what it means. The success rate is very low. Once it has been successful, its rewards can be enormous. Here the point is manufacturing. Once a drug is approved by Food and Drug Administration, the pharmaceutical companies will start manufacturing. They're having two processes. One is the integrated continuous manufacturing process, and another is batch manufacturing process. What does it mean, continuous manufacturing? Which is continuous manufacturing shall be held at the same time of the previous feed material gets processed without intervention on and intermediate test cells. But during the batch processes, if one's product gets manufactured, um, um, actually what happened, the before the manufacturing of the product, each and every the chemical should be get it treated up, or it needs to be like crystallized. So for that crystallization, it needs some kind of time, or it takes some marination process is required for that, so that one product gets generated and it will keep rest for some days or months or some boundary limit time, and after that that process gets eventually get it rationalized, then that ratio is get it processed again. So it takes month or years. So that is what called batch manufacturing process. But it is nothing. But in integrated continuous manufacturing process, is nothing but in one shot. If one product gets ready, and that is a feed for the next one. So the final process result will come in an instantaneous manner. That is what the difference between batch and integrated manufacturing. So come to a distribution. This involves packing, labeling, and shipping the drug to the pharmacies and other healthcare providers before the expiry. Pharmaceutical companies must also ensure that their drugs also stored and transported properly and ensure the safety and efficacy. Pharmaceutical industry product is not like our oil and gas or power things and all. This is directly deal with human beings, so it should be properly stored, and and then before expiry, it should reach the customers. We know that the medical instrument manufacturing, we have plenty of diagnostic and therapeutic and monitoring, which includes cardiology, lung functionality, and kind of articraft and noise mitigation we are using. So this kind of industry is also our instruments being getting involved. So here you see for the you have been seen in the normal days X-ray machine, the MRI scanner, ECG machine, EEG, pulse machine, dialysis machine, endoscopy, dental machines, and then orthopedic instruments. All are comes under instrument manufacturing. So we are involved in this process as well. And we come to the air traffic control system. Here, in the air traffic control system, which is designed by run by the Federal Aviation Administration, the air traffic controls device system divisions are there is two major things are there actually. So terminal radar approach control and then air traffic control tower. These all the both controls are physically available in all the airports you can able to see. This is the air traffic control ATCT, and then the terminal radar approach control. This is one track on. So what happened? These two peoples are air traffic control system command center is responsible for oversees all air traffic control. It also manages all traffic control within the centers where the problems of like bad weather, traffic overload, imperative runways, for these kind of activities they have been taken care. And air route traffic control centers, ARTCC, this is this is each and individual area, like area means control centers having this kind of a part. Each ARCTC manages traffic within all sectors and its center except the track on airspace and local airspaces. So these are the guys responsible who the track on this track on is responsible for the departing and then parking, then aircraft takeoff. So until this action, this guy is responsible. Air traffic control tower, which will see all the takeover, landing, ground traffic, these all the things are handled by him. So how we are coming to the control system environment, this for controlling the all the aircrafts, we need signaling, we need some kind of parameters to be monitored. This all the things are handled by handled in the fundamental of instrumentation and control system. That is what here it is mean. So in the aircraft system, in the aircraft itself, we used plenty of navigation systems like instruments we have to measure the to measure and control the position and direction of aircraft, also the performance of aircraft. So internal external pressure, temperature, altitude, run indicator, speed control, head indicator, humidity, fuel level, wind speed and all we are monitoring while we are flying in the aircraft. That also includes our instrumentation, monitoring and control over there. Okay, so coming to the topic of industrial 4.0, some of our earlier eminent speakers already been covered in this big data analysis, robotics, simulations and system integration, Internet of Things, cloud computing, additive manufacturing, augmented reality. So you have been enough knowledge on that, I hope. So finally I'll come to cyber security systems. So I'm going to give a overall overall idea about the cyber security which we are dealing with it. In the upcoming session, the gentleman from TCS who is going to give the detailed cyber security presentation over there. I'm just giving an overall on it. So it is a practical approach of protecting systems, networks and programs and data of malicious attacks. Malicious is nothing but malfunction attacks. So this is what cyber security means. It is a practice of protecting systems, networks and programs and data. That's it. This is what the thing cyber security does. Here I'm having a short video on it. We will just see that video and then we'll come back to here. See, she's getting a mail for this shoppingcrat.com. So she is entering into it. She has all the informations on the website itself. She have put this mail ID, numbers, everything is there. So these all the information are stored in the server. One day she received an email wait for the gift voucher. So she's filling his email ID, phone number, banking details, all these things. So this is a fishy now. So once she entered all the details, on some time she got a message like his money was taken by someone else. This is by the hacker. So who's doing this? So how he does, we will see. So she don't know it, how it was gone. So we are analyzing now how it was happened. So this one you can see it. This is a malware attack. So she is getting downloading some of the things which comes under email. So from that, once she get click on the download attachments, that but having the link of this fishy person. So this hacker put his link on it. So if once she clicks, she can be controlled by this hacker. So this system is completely taken care by this hacker, and then he can able to access all the personal informations of the person who intend to do it. Then after that, he's taking the money and taking the information, and then the further consequences are going ahead. So this one I will detail you one by one, by the word, because if you can able to hear it, then it will be fine, but you cannot able to hear it. So okay, so I will go ahead there itself. Okay, so here we having two types of cyber security. One is information technology and another one is operation technology. Information technology is nothing but the enterprise data protection. It will protect only the data. But operation technology is nothing but industrial process protection, which we are using. For us, for industrial point of view, operation technology is applicable. Here, the difference between the both. Here, the business property is confidentiality. For IT, all the data has been getting confidential, and data integrity is a key for them. Windows and computer servers are their protective equipments, and the working environment is air conditioned. Regardless, for us, for the OT, we having the business availability. Always we needs an availability of the plant in order to get the production more. And then the control process cannot tolerate the downtime. We should not get it shut down anymore. And then industrial legacy provides like a PLC, programming logic control, human machine interface, matrix, etc. And the working environment is harsh. Like in the extreme temperature, we're going to use it. Also, we need to work on it. Here, if we are coming to the information technology, managing data for business like banking, insurance, software companies, etc. Use of computers for information processing and managing data via software. It contains servers, networking devices, and endpoint devices. This is what our information technology has regarding the cyber security. This is all the areas they are working on. Now we come to an operation technology. Here, hardware and software that detects the change in production and operation through direct monitoring and control of physical devices. We come to know that any kind of production or operation changes while we are monitoring it, then through the operating technology we can able to see that. To prevent the downtime of the industries and ensuring plant security from people safety, environmental asset, and production. Industrial compounding equipment like IoT gateways and industrial control systems like distributed control system, supervisory control and data acquisition, and programming logic control. These are all the ITs. This is structured query language. These are the terms which used in IT in our cyber security system. Standard query language, cloud, and then CRM. And then this is CRM is nothing but corporate maintenance, and then enterprise research protocol, and then remote desktop protocol, and hyperlink text protocol, and internet access. For us, it is machinery, assembly lines, remote terminal unit, human machine interfaces, supervisory control and data acquisition, programming logic control, and modbus communications. These are all our terminology here. So here, what type of cyber attacks can happen here? Malwares. They are sending an email to us, so we are downloading in, so that we are getting access by the hackers. So for prevention of it, stop clicking the suspicious link and updating firewall and operating system of your PCs. And phishing via email, they ask to click the link and update personal informations like we are from Amazon, we are from Flipkart, we are giving you offer like this, so please click on it. So please don't do that. So if you're clicking that, it will link to their fishy link, then you will be hacked. So that the phishing and malware is a common thing which normally we are facing in nowadays. And then password attacks through the bank password and dictionary and keyloggers attacks, they are entering into our vicinity. And then preventing that, updating your password frequently. Use alphanumeric whenever you are using your password. Not only like a random word like Google, not like put like this, like Google GOO at 123 or something like that. If you put alphanumeric, if you use it will be more protective. Don't use any dictionary words because it is easy to get it find it out. And DDoS, distributed dental of service. This denial of service is like a multiple connected devices they will send a more information to your PC, and then they will hit hang on your PC. Once it gets hanged, they will take a complete control of it through their regular software, some kind of ransomware and rug software, like some kind of softwares are there. They are through that they are entering into our firewalls, and then they will come to your system, and then they will hack your systems. So for protecting that, we use regular software updates, online security monitoring, and recovery managing should be updated. Why recovery management to be updated? If you have any kind of problems, or if something gets hacked or it gets trashed, you need to get to the restore the original position of your systems and information. So that recovery management is very important to be get it updated. And man in the middle, what this guy will do, if you're dealing with the if you're dealing with one bank, he will he may already access to your PC, but he will wait for the transaction to be happened between you and the bank. So once you are sending the information, that time what will do, he will hack your IP address. From there he will enter into your proper line, and then he will be talking instead of you, or he may taken all the information from you, so that you will be getting cheated easily. So for protecting that, use the encrypted website. It should be started with HTTPS / and double colon. So these kind of things should be there always in the website. For example, if you see here, I'm just putting. See here, I'm just putting Google, something like that. I'm putting anything here, then I'm just copying this one and pasting somewhere here. This is coming with HTTPS. This is the protected website. This should be like this. All these links you see, no? These all will start with HTTPS. So these are the trusted websites which you can able to find out whether it is right or not. Also, it's drive by download. Don't download suspect attachment which we've seen. And then avoid visiting any offer or unauthorized websites, so that you can able to be protected from there. And malware, it is a malware advertisement. Don't click on the advertisement. Use the ad blocker in the Google Chrome or Mozilla Firefox, anywhere else, and the regular software updates. And then we have to use our common sense. For seeing the advertisement itself, we can come to know that whether it is fake or real. And then this rogue or ransomware software, these are all the main killer softwares. And then if using this software, they will entering into our website. What they tell, they will inform us there is a virus alert on our PC, so please clean it. And then they will encourage you to free trial program, then please use it. And likewise they will tell. And once it has been used, then the PC will be slow down, then it will be hacked by themselves. So that please don't do that. So for that update, we need to update the firewall and use efficient antivirus on your systems. Then it will be fine. So now how actually this is the fundamental of cyber security, and then the way of getting hacked. So how it is related to us. So cyber security in information technology, it is a broad term that it covers software, data information processing, and includes endpoint devices like computers, servers, and all that it is encompassed with. So the information technology is completely dealing with data and information processing. But unless the operation technology is responsible for managing and controlling the system, generally in the factory setting. Now see this here in this picture. The level 0 is our field devices, whatever you see in all the transmitters. The controls all like our controllers, which is in the control walls or whatever this wall. There are the level 2, and then the level 2 is our third party systems, like the safety instrumented system, safety integrity level, and then the third party system. These all comes under level 2 session. And this is basic process control system is our protection level 3. So what does it mean for this level? We are segregating our process instrument into the safety level of 0, 1, 2, 3, 4, and 5. So these all are the safety level which we have categorized. Accordingly, we will protect the system as well as our plant. So for field devices, we consider level 0, and controls level 1, and then the supervision, like all the supervisory systems are under level 3. The production control systems and then plant admin comes under 3, and the plant DMIs. What is it? DMIs? This is demilitarized zone, we can say. So demilitarized zone, this is a term called in plant. These all the plant vicinity is called a demilitarized zone. So this is comes under 3.5, and then the operational technology and information technology of the cyber security and common services comes under level 4, and then enterprises demilitarized zone. This is a complete system which is called level 5. So OT will be covered until here, until the plant vicinity, and then after that IT will be taking care. So finally IT and OT are separate fields, but IT and OT convergence is becoming an increasingly appealing option for engineers. For us, we are dealing with both IT and OT in order to get safe our plant from the malware attacks. So let us conclude the industry 4.0. The benefits is increased efficiency, reduced costs, improved the quality, and increased productivity. In addition to that, the business become more agile, and they can quickly adapt to the challenges, condition, and customer needs. It allows for the process to be controlled with minimal human intervention, process value, and more reliable as well as faster in response. But in the meantime, we having some challenges as well. Cost for the implementing this new technology is high, and the skilled worker is less nowadays. Hopefully in the future they may come more, and the integration with the existing facility, the plant which we are having now. So some of the plants we don't have this kind of facility to be getting integrated. So these are the limitations for us. And then the ethical completion is when we are advancing the technology, we lost the manpower. The manpower need is like limited, so that that's what the point it is mean. The technologies can be used to automate the process and replace the human workers. So these are the advantages we begin with. Here finally we come to the summary of it. The future of instrumentation and control system is bright, and there are many exciting possibilities for the future innovation. This is an existing the exciting time for for the industries, and possibilities are endless. It may improve more, like 5.0, 6.0, 7.0, more like that. So this is what from my presentation. If you have any kind of queries, please.
Thank you, Sir Balan sir, for your excellent and interactive speech. Your presentation is it is very clear. We have no doubts at all. At early morning in Qatar, you are spending your valuable time with us. The way you started with the industry 1.0 to 4.0, how offshore oil rigs work, subway pipe arrangements are really amazing and interesting. We get to know about hydrogen sulfide, which is unwanted and dangerous, which is to be handled very safely. Also, you started with the basics of instrumentation, parameters, difference between the analog and the digital, and moved to trends in instrumentation like AI, AR, and VR, and various industries, and finally ended with the cyber security. Everything was very nice. The sequence of your talk is very easy to understand, very useful and informative, sir. You had put a lot of efforts for this session. From the starting itself, you are continuously communicating with us to know about the target audience, the topics to be covered, and about the topics of the previous speakers. So you clarified the doubts regarding the presentation in Google Meet with the trial session. I wondered and surprised about your dedication. I thank Dr. N. Dhanashekhar sir for suggesting your name for our invitation. Really, we are very proud and thankful to have you as the eminent speaker of this session. Thank you. Thank you very much, sir.
Thank you so much, madam. I want to thank my professors who I am now. So without them we are not giving like built it up, like our Ravi Kumar sir, for the microprocessor and microcontroller. He was like he was studied, he teaches like anything for us, and then I learned many things from him. And then Dhanashekhar sir for industrial instrumentation. Without him it is not possible today for me. So he have taught like very very virtually, and then he trained us a lot. And then for fiber optic communication, Muttumari madam. For electronic devices, Shailaja madam. And then for electrical machines, Chitra Devi madam. And these all are the, and then Mr. Syed Fairo sir for the measurement and instrumentation, Arun Balaji sir for the biomedical instrumentation. So we learn a lot with our, the faculty members, and then our professors and the associate professors. Without them, I am not here today. So I really thankful to all of them. Keep learning, and then we will get into the touch with the future industries.
Thank you, sir.
Thank you so much, madam.
Thank you, Sir Balan, sir. Thank you so much.
Thank you, madam. So I can leave the meeting now?
Yes, sir.
Thank you, madam. Thank you.
Dear participants, the feedback and assessment link for day 4 will be posted in the chat box at the end of today's afternoon session. Kindly join at 1:45 p.m. in the same link for afternoon session. Thank you.